Hello. Alright, so why is this failing? Nice. I've been toiling away the last week and a half writing a shader language and a compiler. So I haven't made much progress on the API front. Yeah, I just went ahead and made my own shader language that gets transpiled into GLSL and HLSL. So I'm working on that now. I haven't started Vulkan yet. My plan for Vulkan is I'm going to generate GLSL and then compile from that. Hello. Alright, but right now I'm working on the build tool. So where... This is what my shader language looks like, by the way. It's inspired by HLSL. So you basically specify your inputs and outputs. Yeah, so it basically it's HLSL with a few syntactical differences. So yeah, you have like the shader stages. You have like a vertex shader, the fragment shader, compute shader. I don't have compute supported yet. But yeah, so you basically just like set up your vertex like input, output, fragment input, fragment output. These are just structs essentially, right? Like your HLSL, you do this. You give it a semantic. You can also set these as like packed, which I'm actually working on today. I'm gonna make this work. But then yeah, you can like set up constant buffers for like shader uniforms. And then yeah, write your main function. And the cool thing is when I compile this, so here it is in HLSL. So this is the generated code that the compiler outputs. So it takes this shader here and then compiles it and splits it into HLSL, which yeah, so here's like the vertex shader from that, the fragment shader. But I can change to like OpenGL and then rebuild. And now I'm in OpenGL, right? But it used the same shader language. So it took this shader language and compiled it to GLSL. So here's the GLSL that it generated. And it sort of does the same thing. And it like is aware of like semantics. So like in HLSL, you write position, like from the vertex shader to GL position. So it can like make that sort of translation for you. But yeah, essentially it's just a universal shader language that gets compiled into each backend language. And I'm gonna have Metal as well once I get the Metal backend implemented. But yeah, it's still a work in progress. It works on this simple shader, but I don't have like any of the intrinsic functions implemented yet necessarily. So like you can kind of see what's going on if I compile this for HLSL. Like here's some things you have to think about. Like, okay, so the mul intrinsic for multiplying matrices. In HLSL, that's the mul like function here. Like you take in a matrix and like a float or a vector, but this is a function. But in, and you can see that that gets spit out here like this. But if you go to OpenGL and compile, oh, the game's running. Yeah, right. Takes forever to compile. OpenGL, the mul intrinsic is just an overload of the like the star operator, this guy, the asterisk. So yeah, the shader language has to like be able to convert between the intrinsic functions, and I just need to build those out. So I haven't done that yet. I just have like a few of the core ones in, like multiply and like sampling textures as well. I have those implemented. Yeah, didn't the source code for GTA 5 leak like a couple months ago? I remember I peered through like a little bit of it that I saw. I saw a snippet of it. Unfortunately, the toaster renderer is not working right now. I have broken the toaster. I'm in the process of rebuilding the toaster though. I have to get the shader. I have to re-implement the shader for the toaster. It's going good. It's going good. I know, it's sad. I spent the last week writing a compiler. So in the process, I've broken the toaster. But hopefully today we can get the toaster back. Here, let's see. Maybe we can get the toaster back today. Let's try it. If I try to run the toaster engine, the toaster project, I think it just errors out on me. It doesn't have the shader. Yeah. So I need to re-implement the shader. So let's just try doing this. I'll be surprised if this works. Yeah, I work in AAA. I work, actually work on Call of Duty. One of the studios that works on that. It's a, it's a pretty big engine, pretty big code base. I just got off work like an hour ago, actually. All right, so let's see. I need to implement these two shaders to get the toaster back and running, back up and running. Yeah, I'm also a graphics programmer. Is my day job. So what do we do here? This one doesn't do anything. So maybe I don't need to implement this shader. Just do this. delete. Let's see if this compiles. All right, what am I missing? Okay, so I just need this shader now. And this one does a lot of this stuff. I'll be shocked if this works first try, to be honest. The toaster is close. I don't know if this will work though. That's why. Alright, now we just need to implement this. Right, in theory, the toaster should work. That's already bound. What do I call this? Yeah, so I haven't really gotten a ton done since, like, visually. I've been working on the shader stuff. So I've made a lot of progress actually in the shader front. It just doesn't look like I have. So let me just, one second, let me see this here. Matrix model is part of this. All right, global sampler. That definitely should have generated that. Oh no. Yeah, so I guess to answer the question better, I've been working on the shader system for the rendering backends. So ultimately, I just wrote my own shader language and a compiler for it, which compiles this shader language, like this one file, into the individual backends. So like, you write shaders in this language, and then if you're on OpenGL, it compiles this into GLSL. If you're on DirectX, it compiles it in HLSL. If you're running Metal, it'll compile it into like the Metal shading language. whenever I get around to implementing Vulkan, it'll compile this probably to GLSL, and then using, I think it generates to like SPIR-V or something from that. I don't have Vulkan implemented yet though. But yeah, so the idea of having this shader language is that basically when you're making a game, you don't care what graphics API you're running. You just write shaders and then they work. And it's kind of not trivial to do that basically any other way, because writing my own shader language compiler, or my own shader language with its compiler, allows me to do some clever stuff as well. Like in the shader language, you have to specify a vertex layout, right? Because you have to like bind these things so the GPU knows what data goes where. So if you're already specifying a vertex layout, since I have a compiler, I can just spit out C++ code from this to like interface with my graphics backends. So in my engine, specifying like unique vertex layouts for shaders will be as simple as just writing the shader, and then it generates like a C++ struct with this name. And then in your C++ code, you can just write directly to this, this struct. It's just like a representation of vertex data. And it's just specified in this .shader file. So it's like a one-stop shop to just have everything else work. That's the vision. I'm like partially, I'm making baby steps towards getting there though. Like this does work. I just demonstrated before how like I can write this shader and then switch between OpenGL and DirectX. I don't know what it's mad about right now, actually. I lost my train of thought. Okay. Yeah, so I'm getting an error with the DirectX outputs. But yeah, we can see like, so this is the shader we just wrote for like, I don't know, the shadow mapping. So this is like a simple forward rendering for shadow mapping. So these are the generated outputs. So here's this shader in HLSL. So you can see it basically generated a vertex shader program with like your inputs and like your main function. And here's the fragment shader component of that. So this is just the code from over here, just compiled into HLSL. Now here it's mad at me because it's saying that this this global sampler thing doesn't exist, which is actually kind of a hack. So it doesn't surprise me that this doesn't work. But if I look at this code, you can kind of see what the problem is. So it's like right here, in this shader, for instance, you can see where it's generating these texture, like texture 2D, and then the sampler, like here it is here. But in this shader, for some reason, it didn't generate it. And I think I know why. I just have to look. But yeah, the actual implementation of the shader, maybe I can make this a bit bigger so you guys can see. Yeah, so like the shader has basically 2 stages to it. I guess technically a 3rd stage because I do dead code elimination. But it has a parser, which just parses this .shader file, and then basically parses it and then builds an abstract syntax tree, which is like just a sort of an abstract representation of the shader program. And then there's this little optimizer stage which just traverses the tree and then eliminates dead branches. Like so if you like wrote a function that's not used anywhere, it just doesn't output that code. But then there's these this backend, these generators. So this is what actually builds like the HLSL or GLSL output files. So this is where, I just, so like here in this function, it's like getting semantics by name, and it just sort of takes that abstract syntax tree and then figures out what to do with semantics based on the language. Because like HLSL uses semantics, but GLSL doesn't. But GLSL has some built-in ones like GL position or like GL frag chord or GL depth. So it kind of piggybacks off the semantic system in order to figure out which of those to use. So if I come into where it's generating textures, so here it's generating the texture, I guess, output lines. And I had this little hack in here. So this is what's going wrong. It's this static thing here. So maybe if I just put this out here somewhere. It's like put this at the top of the file. And then I'm gonna make this a bit smaller so I can actually see what I'm doing. I just got distracted. I can just come up here and I don't know if GSL has this stage. Or HLSL, I mean. So in theory, once I fix this, we should be able to see the toaster. There we go. The toaster's back. The text is all red though for some reason. I'm not sure what's going on there. The toaster. It's literally just a flying toaster. Okay, I'm actually really happy that that worked just so quickly. Besides the one little bug I had to fix, because I haven't tested the shader language too thoroughly yet. Like I just got it working yesterday. So the fact that I could just write these shaders and they immediately worked is a good sign. Now I would test OpenGL, but my OpenGL backend is not very feature complete yet. But let's just see what happens. Yeah, no surprise. Invalid operands to. What's it mad about? We can fix the text while we're at it. There we go. But yeah, so what I want to do now, what I want to work on now is, so I guess like the overarching reason why I did this is in the backend. So this is the rendering backend for DirectX 11. So I have these like backend functions, shader init, which like initializes. Here it actually compiles the shader. Eventually I'm going to move that to the build tool. But here is like it's setting up a shader. This would run at like engine start as like part of the boot sequence for the engine. You can see I have like some to-dos down here. So like part of initializing the shader is you have to specify the input layouts for the vertices or the vertex format. So here I just had these hard coded in to like the shader. So that means that every shader I created had to have this exact vertex format. But now that I have my own shader language that I'm generating code from, I can just extract this information from the shader. So I'm going to be generating a table of these things. And then from the table, it will be able to find the correct input layout, this like D through D input element description. So when I come to like initialize a shader, it'll just pull the correct description for the vertex format that you specified in the shader code. So in order to do that, I basically have to map, like here, let's look at the shader code. So here's like my vertex input. Maybe I can put these side by side. Yeah, so like here's my vertex input. Here's like the corresponding input description. You can see like position semantic. So this is the position semantic. And since this is a vec3 or a float3, like I have to supply this like R32, G32, B32 float format, which is essentially just a 3-component 4-byte float, I guess, representation, right? So it's a float 3. And then like the next one is like, okay, I have UV. And in this engine, I actually pack the UVs as uint 16s. So like 2-byte integer values, because like realistically, I'm not going to have a texture that's more than 65,000 pixels wide. And for texture sampling, it doesn't really make sense to have like sub-pixel UV accuracy. So yeah, I packed the UV coordinates as 2 bytes per channel. So like that's what this, I guess, pack as uint 16 will represent. It's like, okay, I have a float 2, but in the input layout, I want to pack it as a uint 16. And the color is kind of a similar way. It's like a color has 8, like a 1 byte channel. So like 8 bits per channel. But in shader code, you still like work with it as if it's a float, right? So it's basically just a matter of, okay, I have this vertex input. Now I just want to generate this from that. So yeah, let's just do that. So let's see. Trying to think of how I want to actually structure this. There's like a crazy thunderstorm going on right now where I am. I keep seeing like lightning flashing out the window. All right, so I think maybe the first thing we should just do is get it to like print to the terminal. before I go about trying to like actually save this stuff. So let's just copy this. So where we generate the structures here. I'm using C++ 20, I think, or at least features of C++ 20. Admittedly, my C++ is just kind of like all over the place. So let's see, input, let's just write some gross debug code here. Input description. Well, here's where I loop over these. False. False. I actually am only a Java programmer. So why can't I think? Have you been trying to learn C? C++? You take me as more of a C developer, actually. So what are these things called? Do I store these anywhere? Where am I? Java mentioned, true. True. So what am I doing? Type variable. Okay, member variable dot semantic. And then, so case semantic type. This is just really gross, but we will clean this up later. The important thing is we get it working. Format, which is going to be kind of a pain. Format. Yeah, I just gotta stream for fun. When I stream, I just stay more focused because I can't just go distract myself on like YouTube or something. Alright, semantic. Oh, I skipped semantic index. So I have to append this guy. And that is just true. What am I drinking? That's a good question. I'm drinking something that is liquid. Okay, we actually have to count these. Int, semantic, index, and this is an array of it's a secret. I don't want to give away the secret sauce to my hydration. All right. Semantic index plus plus. Oh, wait, what am I doing? Let's do this. Such fun music. All right. So now I can just print this bad boy. Put that here. And next up is the format, which is going to be the difficult one. So for now, we'll just spit out something stupid like this. And then what are these? These are like byte offsets or something. Input slot. Wait, I thought I did that already. Is it just 0? Or is this based on... What is this? Fascinating. Let's put 0 for this for now. Aligned byte offsets, this will be fun. So we'll have a, I don't know, unit 32. Just make this an integer. And then we have this. And then last we have the instance data step rate. I'm not even sure what that means, but I know that's 0. Alright, here we go. So does this look reasonable? I'm missing the new line character. Alright. Wait, why is that not writing new lines? All right, so that looks like it works. Looks good over there. Now let's figure out this DXGI format, because this is going to depend on the pack type and then the variable type itself. So we need to like classify these types somehow. So what are the options for this thing? Oh, actually. All right, yeah, thanks for stopping by. I would stream earlier, but I'm at work most of the most of the day. All right, let's see. This is annoying. So there isn't a 3-component format for this. So you just have to use a 4-component one and ignore the last channel, which I guess is fine. All right, I think that looks correct. But this exists. So that could be 12. Just this doesn't exist, does it? Yeah. And then and then if I add just another thing in here, like let's add failed to create input layout. Okay, that's just not in there. Yeah, there we go. 2, 4. I don't know if I like having all these types. Okay, so this does matter. It's fascinating. There's signed normalization too. Wow, that's so annoying. When will I ever use that? Probably never. Really, I should generate this as like a table. It's like a two-dimensional lookup table. Instead of a giant switch statement. Okay. Suppose I should just support normalized versions of these as well. Hello. So unorm doesn't exist for 32-byte. I've been streaming for about, I think, an hour now. Hour and a half. Let's see. Yeah, that happens pretty frequently. Usually I'll try to just work on something else or just stop. So these are wrong. Yeah, it does matter, and I can show you why in a second. I just have to fix this compile problem. I think I have another one I have to work through. What's it mad about? All right, yeah, it does matter because like you can see here, this kind of looks normal, right? You have like the textures the correct way. Like it looks normal. If you use a different enum, let me see where this is happening. 1 second. So basically what I'm doing is I'm generating this struct right now is kind of like my end goal, or generating this little description here. And I'm filling in these enums, but these matter because like you can see that this is an R16 G16 U norm, meaning that the value that the shader sees is a normalized, basically floating point. So it's like a value that's normalized between 0 and 1. And I use that for texture coordinates for this vertex format. So if I change this to just be a float, you'll see that now the textures are just completely wrong, right? But if you get like zoom in really closely, you can see what's happening actually is the texture's just repeating like a million times because it's not normalized. So the shader is interpreting this value just like as it is. Whereas like a 16-bit normalized value would just take like the 16-bit value divided by the max 16. It's not that distracting. So yeah, unfortunately these enums or matter quite a bit. Right now I'm just doing this in like a really hacky way just to get it to work first. I'm gonna come in and like refactor this because right now I have this sort of ugly switch statement of doom, right? Whereas ideally this will just be like a 2D array lookup table that can just like you indexed into directly. I need to get this to work first, and then I'll come through and break this into a 2D array. But yeah, you can see that with this, I'm generating, right now I just have it spitting out to the terminal, but I'm generating that bit of code because I'm going to use that as part of the, I guess the engine internal. Now this actually is wrong, I think. Let me look at this. Yeah, because I'm not sure how long you guys have been watching, but I'm working on a... Yeah, thanks for stopping by. I'm making a custom shader language that gets compiled into DirectX, OpenGL. Whoa, Siri just wanted to talk to me, I think. DirectX, OpenGL, and Metal, like backends. So I need to basically sort of take this file and like translate it into HLSL and GLSL. So you can see like here's like the HLSL output here. And part of that involves generating input layouts for like the render backend on the CPU, because when I basically load a shader, I have to tell DirectX how to I guess interpret this vertex input, right? So I encode that in the shader here. It's like the semantics and these pack as flags, because it'd be really tedious if you have to just do that manually for every shader you make. It really shouldn't be a complicated problem, but for some reason shader languages just make it complicated, and I'm trying to solve that. So we can delete this. So like this is what I have hard coded into my backend right now. I'm trying to remove. And if I come in here and I change this to what it should be, a unorm. I don't even have. Yeah. Yeah, I'm just doing some major stitching right now. So I'm just kind of copying and pasting stuff around. Because like ultimately it's like, so I have this compiler that parses the custom shader language file. It tokenizes it. So that's like what these tokens are here, like these token types. So these are like all the keywords of the language. And a decent number of these keywords are just these packing parameters. But then that has to get built into, well, I build it into a syntax tree, and then the HLSL backend has to basically generate code from that tree. So it's just taking a token type and then figuring out, okay, what does this actually represent in DirectX? So right now it's just this ugly switch waterfall, but I will clean that up in not too long. But where was I? Yeah, so if I need to actually add these to my if I come in here and I do unorm 16 and compile, I need to fix. So in theory, these should be the same thing. Oh, it's missing position. Oh, I'm not specifying. Yeah, here we go. But yeah, and like, so this is DirectX 11. Now OpenGL is going to do a similar thing. I guess OpenGL does it in a couple places. I think it's in shader bind, maybe. Or no, vertex buffer. Yeah, so like here's what this will have to translate to in OpenGL, right? So like here's your floating point representation, 3-component floating point format, 2-component, unsigned short, unsigned byte. Now OpenGL, I think, normalizes it for you. So it's kind of annoying because each backend or each shader language kind of like does its own thing. So you have to be really careful about making sure the behavior is like one-to-one between them. Like, what even is this? Yeah, here we go. So it was like a normalized flag as well that you pass. So let's see. Yeah, so like I kind of like the way OpenGL does this actually, because OpenGL, right? It takes where was I? Like it takes in like a dimension, a fundamental like primitive type, and then a boolean whether it's normalized or not. Whereas DirectX has this like big list of DXGI formats of like all the different permutations you can have, just sort of encoded in this like enum table, this enum list. So like I think my intermediate representation should be more like OpenGL, where you have a primitive fundamental type, you have like a component count, and then you have a normalized flag. And then I would just translate to these based on like the table somehow. But I guess that would be like a 3-dimensional table, should not be ideal. But yeah, we're generating this now, so we can actually start to output this. I think the shader should store its ID as well, maybe. Or no. Just write C++ code. I know it's terrible advice. Yeah. Thanks for stopping by. The toaster lives on. But yeah, for C++, I would advise keep it simple, because it's like really easy in C++ to like overcomplicate everything, because like, I don't know, I can kind of rant about this for a while, but I feel like a lot of the C++ sort of standard things that you do, it's just like once you do one thing, you have to do like 5 other things, and then next thing you know, your code is just 90% just boilerplate that you need in order to actually do something under this like construct. Like, think about like constructors. It's like, okay, you have a constructor, so now you need like, you're following modern C++ sort of best practices. It's like, okay, I have a constructor. It's like, okay, now I need move semantics. Oh, but now I need a copy constructor. Oh, now I need a destructor. Oh, now I need an assignment operator, or assignment, like a copy assignment. Oh, now I need a move assignment. And it's just like, yeah. It's just like, you don't need any of that, right? Just keep your code simple, and it's easy to reason about. It's like one of my biggest pet peeves is just like adding things for the sake of adding things. And C++ really encourages you to do that. but it's not necessary. It's simply not necessary. Okay, so like a lot of the times, yeah, I just treat it like C, with some of the nice features of C++. Like I like references. I like templates, kind of. I don't know. I like the idea of classes. At least like having functions as like members of classes. I kind of like that. I'm not a big fan of, I don't know. I like operator overloads to an extent. I like function overloading. That's like kind of the main. Oh, I like namespaces. Those are nice as well. Those are like the main features from C++ I actually use. But the rest I just don't really... Like I don't, like in my project, I don't link anything from the C++ standard library. So I have like I have nothing from the C++ standard included in this engine. Everything I include is like C headers. And then part of that is just because I didn't want like the compile time hit that you take when you include anything from the C++ standard. It's like you can take your compile time from like literally milliseconds to like minutes if you're not careful. Alright, what's this erroring on? So now I have this in the back end. So let me just print this out. Why didn't that print? Oh, I'm in OpenGL. Okay, cool. But yeah, I mean, modular code's easy, like easy with C++ too. Like almost doesn't even depend on the language. Yeah. Yeah, I like operator overloads for like trivial things. Like if I'm like writing a custom like list container or something, obviously I would expect to be able to like index into the list using like the bracket things, like these things, right? Like that's nice. Yeah. Yeah, C++ just gets wild. It's like you'll have like standard like vector of a standard optional, which is like a standard unique pointer of like some type int. It's just like, what even is this anymore? It's like the stupidest syntax ever. And people like unironically like it. It's crazy. Like, admittedly, you do get used to reading it, right? Because like you'll just gloss over kind of all the fluff. Like you'll see like STD : and it's just not. It's like you'll immediately see, oh yeah, it's just from standard library. Yeah. Alright, so I need to generate this now into a lookup table. So let's do this. In here we will include so I need to save these files. Wait, what is this? So now we're generating backend file. Now we just have to write to it. I might just implement these as functions for right now, to be honest. And then fix it later, probably. So I need to also include let's see. This. My tab key not work anymore. What do I do? Oh. I'm not sure how to best split up this code between the backends, because like DirectX wants this, but OpenGL doesn't have this specific thing. So like I can't just one-to-one replace it. I need to be a bit more abstract. I'm trying to figure out the best way of generating that on the fly. Ultimately, I should write whatever I want to write into this, though. Like, I want basically an array of these things, right? Oh, I didn't finish my... I want like an array of these. So like actually it'd be like shader, input, descriptions would be an array of like arrays. Right, like here's like, oh, here's the default shader. And then here's like some other shader. That's a different layout. This isn't trivial, right? Because this could have more than one. It could be like this, right? In which case, well, no, I guess it would just be one of these, right? No. Because like I don't know the depth of the second array because it can change depending on which one. So I can't use like a simple array. So I think I'm just gonna implement these as functions. So like I'll have just a bunch of generated functions that return one of these arrays. And oh, mic's acting all weird. So it could be like, oh, shader, input, layout. And then this could be like templated or something by an ID, like an integer. And that would just return one of these things. So like returns, I don't know, maybe these are like static. Be like that, right? And then I can just have an array of function pointers. So I wouldn't even need to template them. I can just have them like that. So I generate these. Maybe have like, so this would be like shader default. Shader, I don't know, colorize. And then I would have a function pointer array that returns this, and it would be like shader input layout equals and then to call it you just do like shader ID, and here's your description. Here's your array. Let's give this like 0. There we go, like that. And then this is what I would pass to this guy. Where is it? Pass that to shader init here, because it needs this. It needs a D3D input element description pointer. It also needs the count. So maybe this returns more than one thing. Maybe this also returns the let's see. I guess I could just array size that thing, but where am I? I guess this could return. This could be like an integer reference. This is like size or count, I don't know. I guess I wouldn't even have to, I could just have these both out parameters. This feels kind of hacky though. I don't know what you mean by that. My favorite syntax. I like the syntax that produces no compile errors. That's my favorite syntax. All right, let's see. The syntax I hate is the function pointer syntax. I'll tell you that. That's why I wrote a macro to hide this. Look at this. Look how ugly this is. What does it normally look like? It's like return type, function name, and then all of your arguments, int, you know, all your parameter types. Really ugly. Hate that syntax. All right. So then, yeah, I'm just gonna implement it like this for now. Let's see. So I need a way of keeping track of this. It's like I just don't know where this code should live, right? It's like, what are the separations of concerns of this program? It's like, should the compile backend know about the code gen for like the C++ side? I don't know if it should. I don't know if it should. But that's the easiest way of doing it. It's just to like generate this stuff in the compiler. This massive, ugly function I have right here. Like, maybe I should spit this out somewhere else. It's like I need to create an additional data type for my compiler, which is like the vertex layout thing. So I'm going to do that. and we'll see where that takes us. So we have down here, let's just like add another thing. No, I don't want to do it this way. Yeah. I think like one of my problems is like I actually get a little too obsessive. It's like the opposite problem of lacking motivation. It's like I'll get stuck on a problem and I just won't stop until I like solve it to the point where it's like maybe not healthy. But yeah, I guess the inverse is true too, where it's like if I don't have something I'm working on, it's just like I kind of sit around not knowing what to do next. Like here, I'm just kind of clicking around, not actually typing anything because I don't know how I want to do this. Pix. Let's see if I can get this to run. Does it run? Yeah, that runs. Let's see if this still runs. Hey. That will fail. There we go. Here's some 3D here. All right, back to this. Let's think about this for a second. So we basically need to generate this backend file, which will be different. It will contain different things depending on the API that I have loaded. So I need like a backend API thing. Because here, shoot, I just deleted the code that I was prototyping. Yeah, this is just like the most simple 3D scene to like test the rendering API. It has like some shaders, some 3D transformations going on, some mesh loading, textures, shadows, different texture formats as well. So it's a good test project. Okay, so let's actually start writing. Let's just do something. So I want to generate this code, and let's just start by so I think the GFX should have like a backend. That's what we need. That's what we're missing here. So here's like the front end. I'm gonna split this into a separate thing. So like, this is the front end graphics sort of output. Front end doesn't care about the back end by design. So here's the back end. And then back end, we'll do this. Well, I guess the back end does care. The front end does care about the back end, kind of. Let's just spit code out. Here, let's just write our function pointer table here. So I'll just to do this. Maybe once I write it, I'll figure out how I should refactor. Do refactor. So I think ideally each graphics backend will have its own function that generates these files. So shader, put layout function array table. So now I lost the code I was typing here. Let's just do it again. I'm actually gonna make this a function. This must be void function. It might be a Boolean function. And it will take a pointer reference and an, I guess, integer reference. And that will be extern. So let's copy this and paste this into here. And then we need to, in the source file, loop through the shaders. Let's see. So that equals for shaders in sort of a list of these things. Shader has a name, which is helpful. And then our final closing brace. Now this should error out on me, but we should have something in here, and we don't. Okay, great. Oh, we do have them in the back end. That's not where that should be. Oh, I'm not in the right project. Yeah, okay. Now we need to change this because I messed up. All right, so here's our table of function pointers. Now we just actually have to write these functions. And we'll do that. Let's see. Okay, now let's do a gross to do for this. This will work. So let's go into here. And let's think. I guess maybe it's like shader, possibly like header backend shader, maybe as another set of strings. now we can write these from here. We have to include build GFX, and then here where we're doing this, so we need the function name. Oh, I guess we don't know what shader this is. Shit. Surely pass that information along, shouldn't I? So compiler calls to the generator. Let's do this in a really gross way. So that just stores it in some global variable, which is disgusting. But that will allow us to do this. Static void shader input layout underscore append GFX shader current dot name, and write the arguments. pics. True. True. Then this function returns, I guess, true. All right. These all need tabs. Then okay, what this look like? Oh, it didn't even do anything. True. This should be header. All right. So I forgot the. Let's see. I forgot the. This guy. Or no. Forgot. Alright, what's it mad about? Why did I write returns? So this is it because this is constant probably? Cannot be assigned to entity of type. Yeah. So I guess this should be constant probably. But for now. Alright, fewer errors. I made this void. That expects a boolean. Missing a new line. And these shaders are just missing their pack value. All right, we have compilation. So that generated us these tables. And now it's just a matter of going to the back end and replacing this with, so we have a desk pointer and we have an integer count. And then we assert that, screw it. So we call this, we give it description, we give it the count, and we will error if this is not true. This and count is this. So let's see, will this work? All right, it wants to work. It wants to work, but it doesn't work. Why? Is it because, let's see here, let's think for a second. Let's print the count, this should work. Should be 3. Oh, it's not. Oh, it is, yeah, okay. So my layouts must be wrong. Let's look at them. These should be U norms, I believe. Or no, those are right. The forward one's wrong though. These should be U norm. So that's probably it. This should be a U norm 16. Now I just lack color, meaning the color's not making it across. Which, so this should also be a U norm. Okay. I just had these wrong. There we go. Boom. Input layouts are now defined in the shader language directly. So say I want this to be, oh, I want this to be a float 16. Because why not? Yeah, cool. Let's just treat UVs as a float 16. Looks about right to me. There they are. Or true, true, true. I'm almost out though. Sad. Okay, that's one part of the puzzle done. I really hate the way this is set up though. It's like the most disgusting code I've ever written. But it has the potential to be great. It has the potential to be great. Let's think. How do I want to refactor that? I just have some really bad spaghetti code going on. So like ultimately, what do I care about? What is the compiler going to generate for me for the HLSL backend? It's going to generate input layouts, and it's going to generate shader binding information for textures. It's going to generate constant buffer bindings. And what else? A lot of things. I should wrap these in the namespace as well. Let's do that. So when I create a vertex buffer, what do I do? Yeah, so the vertex buffer in DirectX doesn't care what layout it is, it's just data. But in OpenGL, that's not the case. In OpenGL, the vertex layout is actually part of the vertex buffer, right? Well, not necessarily. So maybe I should move this. I don't think this is in the right spot. This should probably be in the shader binding code, if I had to guess. Whereas in DirectX, let's see. Yeah, in DirectX, it's part of the input layout on the shader itself. And then this gets bound when you bind the shader. Yeah, you set the input layout. Whereas in OpenGL, for some reason, I have this in the vertex buffer, which I think is the wrong spot. This should be as part of the shader. Like this should be down here, probably. Oh no, where's the shader binding? Yeah, it should be like down here. So that's something to think about. So if I come into this project, let's test that this is actually working though. So if we have a default shader, we create a second one that is a default, I don't know, different, default 2. And we change this to be a float 16. Right, that should still compile. But now when we draw the little asteroid things, where is this project? Yeah, so when we draw the little asteroid guys, objects, where am I drawing them? Scene draw. Yep. I'm working on, well, I have the compiler for it written now. So now I'm working on sort of some of the metadata that I can get from the compiler for like the rendering backends. Specifically, I'm working on the input layouts. Basically extracting that information from the shader file itself. So let's see, where am I drawing? Oh, here I am doing them. So maybe, oh yeah, this should work. Let's just set the shader. Yeah, that's kind of what I'm doing, essentially. I'll show you in a second, because it's kind of neat. I've also never done this before, so I'm not claiming to have the best way of doing this. So let's see, shader. That didn't work. Interesting. Is it running the shader though? Did I even edit the right project? Output generated. Yeah. Great. All right, that looks more like I expected it to. I expected it to be completely busted. This is actually a good result. I'm not sure if the color's right, but the result is what I wanted. But yeah, so anyway, as a demonstration, see if I can get this to work. Let's delete this shader. Okay, cool. Yeah, so basically what I'm working on at the moment is, so this is the shader language that I like made, I guess. So this is like a universal shader language is the goal. And then I wrote a little compiler for this that essentially just translates this into the backend languages. So like if you're running the DirectX renderer, it will take this and turn it into HLSL. If you're running the OpenGL renderer, it'll turn it into GLSL, etc., etc. So like this works. So this is like the shader. I can like come in here, like change the color. It's like make it red. See, like now it's red. But we can see like what the output looks like. So here's the generated HLSL code that it basically translated, because we're in the DirectX backend. If we go to the OpenGL backend and compile, so now we're running OpenGL renderer, and you can see instead of making HLSL, it made GLSL code. So I guess like the tricky thing is making sure that these are functionally one-to-one. And what I'm working on right now is so like basically my goal here is I just want one shader language for like all of my graphics programming in this engine, because it's like really annoying if you have multiple graphics backend and like in your game code you have to like think about, oh, I'm writing an HLSL shader, now I have to like copy it and make GLSL and metal. It's just annoying to have to do that. So I made this like universal language that just gets like compiled. And part of that, since I'm compiling it myself, I say compile, it's not like technically compiling, I guess it's like translating. So like since I'm compiling it, there's like a lot of metadata, I guess, from the shader that I can abstract in that process. And one of them is like the vertex formats. Because like ultimately, what does your vertex format matter for? It matters for rendering, like in a shader. Like, why even have different vertex formats? It's like, well, a smaller vertex format is like optimal for like rendering a lot of triangles, right? Because like the smaller the data, the more efficient it is in like GPU cache. So yeah, you specify vertex formats. And in shaders, you have to like tell the API what your format is, right? In order to actually access the data. So in my language, since I'm parsing this anyway, what I'm currently working on is, since I'm parsing this anyway, I can just generate C++ code for my engine to basically handle all of this input layout configuration just automatically. So like, yeah, because otherwise, like if I go to my graphics backend here, like DirectX 11, shader init, like here's like creating a shader. Like I have to specify, this is DirectX, like I have to create an input layout and set up one of these input element description things, which basically just looks like what I generated here. And these are like different depending on your input layouts, right? So like these little tables that you make, it's like array, corresponds to the input layout of the shader. Like OpenGL has this too. Like in OpenGL, it is, I have this in the wrong spot right now actually, but like in OpenGL, it looks like this. It's like you have to like set the vertex attribute pointers. You have to like tell it what primitive type the attribute is. I think this is like, is it normalized or not? Here is like the size or the element count, I guess. And then here's like the byte offset. So it's just like this annoying stuff you have to do. You can imagine if you have a game that has like multiple vertex formats because you have different rendering passes, you would need to sort of like organize all of those yourselves. But it's like you're already writing the shaders, right? Like you're already doing this somewhere. So why can't the build system just figure that out for you? So that's that's the problem I'm solving right now as part of this shader compiler. That's the that's my last week of work right here, is getting this to work. But it's pretty cool because I can just like come in here and change this. Like, I don't know. Like maybe the colors, like based on the UV coordinate. Let's make it more colorful. So like here's like DirectX. Looks kind of colorful. I mean OpenGL. Let's go to DirectX, compile. Same thing. Just works automatically. I could rant for a while. I think shader languages are like one of the worst. Graphics programming in general is like one of the worst fields of, maybe field's the wrong word. It's like one of the worst areas of modern programming because it's just like you have like so many different APIs. Each API does things slightly differently, but also the same. It's like the same thing, but done differently for the sake of being different. And no one can like agree on which one to support. Yeah, that's my rant. At least with Vulkan, like Vulkan is kind of a step forward in that you can like get Vulkan, you can like compile Vulkan, I guess like, I don't know, shader bytecode from GLSL or HLSL. So like they've sort of, rather than just making a new shader language for Vulkan, like they could have easily done, they were at least like smart enough to sort of do this for you. So I appreciate that. I haven't implemented Vulkan yet, but I'm going to soon. But that doesn't solve the problem when you have like DirectX and Metal for Apple. True. It's bedtime, true. Let's see. I can do like in.position as well. Here, in.position.x. I think this is not normalized though, so this won't work. Oh no, an error. I'm missing. See, like my shader language even has, oh no, this wasn't copied by my language. True. Yeah, that's a good question. I guess I could. I think, I don't think I'm gonna do that though, because like I have like a default shader for the engine, right? It's just like a simple pass-through shader of color and vertex information, right? That's like what I use to render fonts and stuff. And I don't think I want to have the shader care about what the blend state is, like the rasterization state, because you should be able to reuse shaders with different blend modes and stuff. rather than having permutations of shaders. But I could do that. Like, there's no reason I couldn't do it like that. Oh, let's fix this. Semicolons, need those. Yeah, like, is it even possible to generate your own shader bytecode? Like, aren't the, I don't know, like, does NVIDIA even release, like, what the, like, I don't know, like, is that even possible? Yeah, I guess I could generate SPIRV, yeah. But that wouldn't solve the problem. That'd, like, only help me with DirectX. I mean, Vulkan. Yeah, and like, what the other problem I'm running into, this is why I'm going to support Metal eventually, but like OpenGL on Mac OS is only supported up to version 4.1, I think. So there's like a lot of OpenGL stuff you can't actually do yet, or you just can't do ever on Mac now that they've sort of deprecated support for OpenGL past like 4.1. So like, I mean, most of the features I use are like below 4.1, but there are some things that like would be nice. So eventually I'm gonna have to support just the Metal graphics API. So it's like if I put a lot of effort into like generating SPIRV bytecode, that would help me for like, well, I guess you can technically use Vulkan on Metal or on Apple using like, I think Molten it's called. True. You have a bone to pick with my way of thinking. Let's get the 3D demo back up. I have to keep changing these shader names because the 3D scene breaks OpenGL right now. Here we go. Here's my 3D scene. But yeah, what's cool is like I can change like the packing, I guess. Maybe not packing isn't the right word, but I can like change these input layout formats just directly in the shader code. So like right now I'm sending UV coordinates as a normalized 16-bit value and unsigned. But if I like change this to float 16, right? Oh, it didn't work. Why not? Oh, I'm not editing the right shader. Duh. I want to be editing this one. So like I can like come in here and change this to float 16. Not like completely bust the rendering. But like it's actually working as intended, right? Like if I zoom in here, like really close, you can see it's just like looping the texture because it's not the format it expected. Like it's expecting a normalized value between 0 and 1, but it's getting a floating point value of like, I don't know, 30,000 or something crazy. But like rather than like going in and like going to my graphics backend and messing around with random DirectX formats, it's just like right here, easy, one line, so nice. And eventually I'm going to generate the structs as well, like the C++ structs that correspond to these two. Because, where do I have them right now? Yeah, thanks. Yeah, right now I'm writing a shader compiler for a custom shader language, more or less. And I just got input layouts to work with DirectX. So now I need to do the same thing for OpenGL. But I want to refactor some of this before I go ahead and do that. Because I didn't do it in a clean way. but as a proof of concept, it works. Now I should really figure out why this is breaking. Let me see. Let's go into OpenGL and try to run this. So invalid operands to multiply. So why is it mad? Which shader is it mad with? This one? This one probably? Yeah, I think so. No, that's not it. This shouldn't be working though. Why does it think this is a... Oh, I see. Yes, that's fine. See, these shader error messages aren't too helpful because these like lost information about what shader is actually failing. So let's just figure out which shader is failing first. This one? No, it's this one. Just get rid of this. I don't need this anymore. All right, that was the problem. No, it wasn't. So flip 3. So is it not this shader? Is it this one? Or is it this one? I don't know. I'll figure that out later. All right, so I need to fix this. This. All right, I know what I want to do. So basically, the Hello. So the shader program has, so this is output. Let's do like header. This is defects.backend generated.hpp cpp. So basically each shader program will have its own little local header and source file string to write to, because part of the compiler, so one part of it is generating the actual shader code, and the other component is generating some of the C++ engine boilerplate code. So I guess one of the problems is actually that shaders can use the same vertex formats. So I don't want to just have like a million permutations of these things. But for now, I think I'm fine with that. So the generator now actually will want to have these two. And then we need to pass these along. And this guy needs to now give the and then so rather than writing this here, we'll loop through the shaders, and then we'll spit out their do the same in the header. That should solve that problem. That looks correct. So now we just need to separate. So the shader program should probably know what shader it belongs to. I kind of hate like propagating this sort of stuff forward. But that's fine. Oh, I can't do that there, actually. I'll just pass in a shader ID. how is this even working? This thing doesn't even have a constructor. What? Path. Where's this being used? I'm so confused. Was that just working by pure chance? Wow, it's crazy. Why doesn't this work? Should be a reference. Does shader program need a constructor? Actually, let's just give it this thing. Incompatible shader type. So if this thing is just a reference, I don't actually need to declare it, right? I can just do this. Just forward declare this thing. Struct shader. If this thing is just a reference. then when I compile, so the shader creates itself. Why is it bad? Let's just give it a pointer. I think that will solve our problems. I don't even need to give it anything anymore. Because it knows what it is. It still doesn't like this though. What is it mad about? Shader type. I see. There we go. So can I not make this a reference? What happens? Shader does not. Oh. A seg fault. That's fun.